filling electrons. So there are rules when we fill electrons. First off, and my rule, have your periodic table handy. You've got the Aufbau Rule, which states lower energy fills first. Hund's rule states that electrons must half fill all of the orbitals of the same energy levels before completely filling the orbitals. In other words, they spread out in degenerate orbitals before pairing up.
Degenerate orbitals?
Yeah, sorry, that means that's the same energy level. Like the three lobes of the P.
So in other words, yeah, if they were going into the PX, the PY, and the PZ,
those are all the same energy, they're just different axes.
Right, if these are all the 3p, if I had 3 electrons to fill in here, I wouldn't fill in one here, a second one in the X, and a third one in the Y. I'd fill out an electron, and an electron. They spread out into as many rooms as possible.
Correct.
Right? So electrons don't like to bunk up if they don't have to.
Right, they don't have to. Now, if you get a 4th electron, if you're in the going in, then they got to start buddying up.
Oh, right, yeah, because they can hold up to 6.
Right,
so a 4th one would have to go into one of these 3.
So as long as they're the same energy level and multiple orbitals, they'll spread out until they're forced to partner up. Pauli's exclusion, electrons spin in opposite directions when pairing up in an orbital.
Oh, so spinning, so we should use arrows to indicate direction?
We're going to have to indicate the electrons with something other than a superscript.
So not an E, but maybe an arrow, huh?
Yeah, arrows.
Because we can say directions.
So we normally use an up arrow to indicate clockwise spin.
Okay, so up, up, and up for these first 3. So I've got 3 up arrows here.
Right, so now that 3p, 3 electrons in the 3p, I bet I can tell you what that is, Mr. Kane.
That's 3p3.
Phosphorus.
Okay, 3p3 would be phosphorus.
Yep.
But what if this was sulfur?
Well, if it was sulfur, then that next electron, the 16th electron, would have to partner up.
So it'd have to go in this first p orbital here?
Yeah, and Pauli says opposite spin, so it'd have to be a counterclockwise spin.
So it can't spin up, it has to spin
down.
Down.
Yeah.
Right. And if this were the next element, which is chlorine,
same thing. That middle box would be filled up with 2 electrons.
But one spins up and one spins down.
Spin down, yep.
Okay. And clockwise, counterclockwise, up, down, left, right.
So we're going to draw something called orbital diagrams, if I take it.
Mm-hmm. And it actually uses these ideas of boxes.
Okay.
Which is kind of nice. So when we draw orbital diagrams, we base it off of the
electron configuration.
Right. Because that's what an orbital diagram is. It's basically just a model, a visual way to see this, rather than saying 1s1.
Okay.
Okay, so each orbital gets its own box. So if this were a P, I'd draw 3 boxes.
All right, if it was a D, you'd draw 5, and an F would be 7. Okay.
Right. Okay. So basically, as I draw this, I've only got 1 electron to fill into this box, so it's going to be pretty easy.
Up orbital.
Yeah.
Up arrow.
Up arrow. We always draw it up first.
Okay.
That's just the way we do things.
Represents clockwise spin. Okay. Sounds good.
Now helium has 2 electrons to draw.
Okay.
They are both in the first s orbital, so we only have to draw 1 box.
Okay. But 2 arrows.
We'll draw 1 arrow for the first electron and another arrow for the second electron. One going up, one going down.
Okay. So I noticed the superscript from the electron configuration becomes arrows.
Correct.
And there's no redundancy.
Basically, this is being drawn visually in the box instead. The electrons are being drawn. So with lithium, we're going to have to draw 2 boxes, one representing the 1s,
one representing the 2s,
and one representing 2s.
1s fills up.
1s will fill up.
Okay.
Because there's 2 electrons in 1s. And 2s only has 1 electron.
Okay.
So we do 1 up arrow. Carbon. See if you can predict what the arrows are going to look like. The first energy level has to be filled.
Yeah.
So 1s orbital is filled. The 2s gets filled, so we fill it up. Now the 2p is where it gets tricky. If you put both your arrows in 2px, you did it wrong. Because Pauli says we can't put electrons into the same orbital together unless they all 3 have an electron. So we can put an up and an up. And the way we do things is we always go from left to right. We never put in the X and then put in the Z. We always do X, Y, then Z.
Yeah, it's a consistency.
Yeah, just be consistent.
I noticed, Mr. Kane, that you drew all 3 boxes for the P, the 2p, even though there's no electron in the 2pz.
Correct, because it's important to know that there's an empty one there.
All right, so always draw the boxes. 1 for S, 3 for P, 5 for D, and 7 for F. So even though they're not occupied, draw the boxes.
2p5. So I have to draw, the first part's easy, right? The S fills up.
So just like
2s fills
electron
up.
configuration, orbital
Right.
diagrams has the same starting point.
Right, same starting point. Now the 2p5, I'm going to have to put 3 electrons in.
Right, so that's how they fill, spread out. Now
And then I've still got 2 more.
that next electron's going to have to partner up.
It's going to have to partner up. We'll do it in the X since we always do things left to right.
Okay,
And then in the Y.
all right.
Okay?
That's right.